Now, for this video, this is intended for converting word equation to chemical equation correctly. So we have two learning targets here. This is just a review of describing chemical equations. So I hope that at the end of the video, you can describe chemical equation and then you can convert word equation into chemical equation correctly. So always remember that in a chemical reaction, we have here on the reactant side, 6 oxygen atoms. And on the product side, there should also be 6 oxygen atoms. So in order for the chemical reaction to take place, atoms here are neither destroyed nor created, which means whatever are the elements present on the reactant side, we have hydrogen and oxygen, should be also present in the product side. Okay, so take a look at the sample illustration that I have here. So why use chemical equations? Why do chemists use this? Number one, this is a shorthand way of describing a reaction. It will be tedious on the part of a chemist to write it in words. Next, provides information about the reaction. Why? Because you get to see what are the substances present in the reactant sites and in the product using the chemical formula. You get to see what are the states, okay, of the product in order for the reaction to take place. And we have the relative numbers of reactant and product molecules that are required. So with this, if you have a chemical equation, it will also help you for a chemist to determine the amount of the reactants and the product needed for that chemical reaction to work, and as well as for the amount of product needed for it. Okay, so shorthand expression for chemical equation, for a chemical reaction is chemical equation. So we have here a word equation. Again, the target is to convert word equation to chemical equation. So let's review. Aluminum combines with ferric oxide. Now here, I did not discuss this in the previous video. Ferric, okay, ferrous, ferric, ferrous. If the element ends with IC, if the transition metal ends with IC, the higher charge is being used. So this is Fe positive 3. If the element ends with OUS, the lower charge is being used here, Fe positive 2. That's ferric, ferrous. And using the old name of the element. The old name of iron is ferrum. So we have ferric, ferrous, ferrosulfate. Okay. Now, we convert this into a word equation. The word equation, we have to convert this to chemical equation. That's it. So we check aluminum, ferric oxide, and then we have iron, and then aluminum oxide. You know now that what type of reaction is this, right? It's single replacement. Aluminum, then we have ferric oxide, then we have iron, and we have aluminum and oxygen. So check, are the elements present in the reactant can be seen also in the product side? Okay, yes. Now, reactants are separated from products by an arrow. So this is the reactants, and this is the product part. Then we place coefficients in front of substances to balance the equation. In front of substances to balance the equation. So if there is no number there, okay, it means that it is 1. 1 mole of ferric oxide. Okay, so we have coefficients written in front of the substances. So we have subscripts as well. We do not change the subscript. What else are involved in a chemical equation? In writing a chemical equation, what else are involved? We make use of the condition. We have to know the condition wherein heat is used here so that reaction will take place. So you have there the symbol triangle, which represents heat. Okay, so aluminum, when heated to with ferric oxide, yields, okay, iron and aluminum oxide. The physical state of substances are indicated by the symbols SLGAQ. So aluminum is a solid, okay. Ferric oxide is a solid. What form here is a liquid hydrogen and and solid aluminum oxide. So energy symbols used above the arrow for decomposition reactions. For the combination, for the reaction to take place, for decomposition, we use um, this symbol, this, or electrolysis. We put that on top of the arrow. So HV, something like that. There's the presence of light, okay, in order for the decomposition to take place. Clear? Now, you've learned also in a balancing equation, okay, that it conforms with the law of conservation of mass, that mass of the reactant should be equal to the mass of the product, okay? The same number of atoms on each side of the equation obeys the law of conservation of mass. Many equations are balanced by trial and error, like a puzzle. But it must be remembered that coefficients can be changed, can be changed. I think there's a highlight for that there, in order to balance equation, but not the subscript. It's a mortal sin to change the subscript. Changing the subscript indicates a different substance. Okay? It's a different substance. It's not the same. So let's have some sample word equations. I'm not going to balance it yet. The purpose of the video is just to convert word equation into a chemical equation. So we have here, when solid copper reacts with aqueous silver nitrate, so solid copper, so Cu, then we have S, plus reacts with aqueous silver nitrate. Do not, you have to do writing formula first or crisscross method. Silver nitrate is Ag positive 1. Ag is for silver positive 1. Nitrate is NO3 negative 1. Crisscross, you will get the formula Ag and O3, and then this is AQ dissolved in water. The products are copper 2 nitrate, so you have to use first your scratch paper, copper 2, and then NO3 negative 1. Cross and then cross, you will have Cu, okay, parentheses NO3, 2. And that is aqueous, we write AQ, plus silver Ag, and that is solid metal. That's a complete chemical equation. Okay? Check the number of the elements present on the reactant side. Is it also found in the product side? That's correct, right? And then I'm not going to balance it yet. I have a separate video for that. After which, then you balance. Okay? You balance. Example number 2. So solid aluminum, I'll write it down now, ALS, reacts with oxygen gas plus O2, and that's in a form of a gas, to produce aluminum oxide solid. So aluminum, positive 3, oxygen 2, negative, crisscross. Therefore, you have Al2O3, and that is solid form. That is in a solid form. That is a chemical equation. Okay, so we had seen the importance of having the previous video, okay, for your chemical equation. Next, another carbon dioxide gas, so CO2, that's a gas in gaseous form, reacts with lithium hydroxide. Lithium is positive 1. Hydroxide is a polyatomic ion, and it's negative 1. Crisscross, you will have Li OH, that's in solid, to produce solid lithium carbonate and H2O. So we have solid lithium carbonate. I'll do the formula writing for lithium carbonate first. CO3, 2 negative. Crisscross, what do we get? Li, 2, CO3, and it's in a solid form, plus water in a liquid state. Okay, that is my third example. So again, if you have any questions, feel free to message Ms. Michelle via Canvas inbox. I hope this video will help you in as you review and prepare for the summative test or for the exam. That ends. Thank you for watching.